Welcome to my lecture series. So today we discuss about extrinsic semiconductor. So in this video, extrinsic semiconductors are formed when a small controlled amount of impurities called dopants is added to an intrinsic semiconductor, also known as the doped semiconductor. So this process called doping significantly alters the semiconductor's electrical conductivity, so making it more conductive than the pure intrinsic material. So extrinsic semiconductors are categorized into two main types, N-type and P-type, based on the types of dopant used. Is a doping process. So doping in a semiconductors is the process of adding impurities to a pure semiconductor materials to alter its electrical properties, making it more conductive. So this is achieved by the inducting dopant atoms, which are impurities that replace some of the original semiconductor atoms in the crystal lattice. The type of dopant, for example, pentavalent or trivalent, determines whether the resulting semiconductor will be N-type or P-type. So intrinsic semiconductor, as already we know that it's a pure semiconductors like silicon and zirconium, having limited number of charge carriers, electron and holes at room temperature, so making them the pure conductors. So doping process, so to the enhance conductivity, impurities are added to intrinsic semiconductors. This process called as doping. And dopant, so these impurities are called dopants. So they can be elements with more fewer valence electrons than the semiconductor atoms they replace. And N-type and N-type doping, so in a pentavalent dopant like phosphorus or arsenic, so added to a semiconductor like silicon, it introduces the extra electrons, making the material N-type. So these extra electrons are free to move to contribute to electrical conduction. And P-type doping is conversely, so when a trivalent dopant, so like boron and aluminum, is added to creates holes, that means missing electrons, so which also contribute to electrical conductions, the material becomes the B-type. So methods of doping is the common methods include solid state diffusions and ion implementation. So what are the applications or in the doping process is the semiconductor technology, so enabling the creation of transistors, diodes and other electronic devices. So next we discuss about what are P-type and N-type semiconductor. So semiconductor PN junction diodes are made up of two adjacent pieces of P-type and N-type semiconducting materials. P-type and N-type materials are simply semiconductors such as silicon or germanium, so with atomic impurities. So the type of impurity present determines the type of a semiconductor. So the process of purposely adding impurities to materials called doping. So semiconductor with the impurities are referred as a doped semiconductor. So P-type. So in a pure intrinsic silicon and zirconium semiconductor, each nucleus uses for 4 valence electrons to form 4 covalent bonds. So with its neighbors, each ionic core consisting of the nucleus and non-valent electrons, so it has a net charge of positive 4. So and it is surrounded by 4 valence electrons. Since so there are no excess electrons or holes in these holes, so in this case the number of electrons and holes present any given will be always be equal. So now if one of the atoms or semiconductor lattice replaced by an element, so with the 3 valence electrons such as group 3 elements like a boron or gallium, so electron holes balance will be changed. So and n type is the addition of replacing one of the lattice atoms with a group 3 atom. So we can also replace by an atoms of 5 valence electrons such as the group of 5 atoms arsenic or phosphorus. In this case, the impurity added of 5 valence electrons to the lattice wire can only hold 4. So this means so that there is now one excess electron in the lattice. Because it donates an electron, a group 5 impurity is called as a donor. So note that the materials remains electrically neutral. So thank you. We discuss in next video.